this example. Why I write a simple example, that's my specialty. So where I'm good at giving a very simple example for a complex topics. Okay, let's say if I started writing this for a factorial, most of you would have stopped watching the video, correct? And in the interview, every time they will not ask you to write a complex example. They would just want to know whether you are aware of the concept or not, correct? All, welcome back to Uncommon Geeks. Myself, Vasant. I hope you all doing well. In case if you see me for the first time on the internet, I'm a content creator. I help people to clear their interviews. I've made a lot of beautiful series in the past, which has been appreciated by many. And in the recent past, at least in last few weeks, I've got a lot of love. Even in less than a day, I've got more than 150 subscribers on my YouTube. Thank you so much for all the love that you're showering on me. I wish you please continue doing the same. Like always, I have only one noble cause of helping a lot of people to aspire to the job that they really want to go. That's the whole purpose of my channel, where I make a lot of videos just by that. I make good amount of research just to come up with the good concepts which are asked in the interview and how to prepare them. So please like and share my channel, and if you're not subscribed to my channel, please subscribe. Okay, now let's get started with this video topic. So that is memoization. Okay, this is one of the very important interview topic. So whether you are looking at it from the perspective of data structure and algorithm, or you're looking at it from the perspective of just the JavaScript concepts or itself. Okay, so whether you're aspiring for plain HTML JavaScript developer, vanilla JavaScript developer, or a React developer, React Native developer, Node.js developer, or Angular developer, memoization is very important concept. Okay, so there are basically two verticals of memoization, how the questions can be asked. Okay, that I'm going to explain somewhere in the middle of the video. So please watch the video till the end to know the different personas and what I'm covering in this video, all of that. Okay. Now, without wasting further time, let's get started by making our hands dirty. Let's start some coding. Okay. So first thing here, let's start with the definition of memoization. This is me, where I always want to give the definition, then only I'll generally start explanation. Reason is I strong believer of conceptual knowledge first, then the practical knowledge. So you need to know what is happening or what is the official definition, because even this will be asked in the interview and they will not allow you to write the code always. So please have at least basic definition, not a bookish definition. Whatever you understood, that definition you need to know. Okay. Now let's see the definition. Definition: an optimization technique used primarily to speed up computer program by storing the result of expensive function calls and returning the cached result when the same input occur again. Uh, Most may understand, but in very simple words, is what is memoization is this. So whenever you're doing a big computation where the computation result is so high, or the computation happen to get the result is so high, then don't to do it repetitively. If there is a chance where you can cache that value, then please cache the value and return the cached value. In very simple example, the factorial program, correct? What is factorial of 5? 120. 5 into 4 into 3 into 2 into 1, which is 120, correct? Factorial of 10, it's a very big number. I can't tell that. Factorial of 20, most compilers, if you don't know factorial of 20, you will not get the result easily. Okay, because it exceeds all the usual data types that we use. In case if you know what is the data type that is used to store 20 factorial in JavaScript, please mention that in comment section. Okay, definitely if you write a let x equal to factorial of 20, then you will not get the answer. Okay, at least what the expected answer, you will not get that answer. Now, see, let's say 20 factorial means when you're doing the 5 factorial, you have already multiplied 4 into 3 into 2 into 1, correct? When you already did the 10 factorial, you already multiplied 10 to 1. So whenever you're doing 20 factorial, again you need not to multiply 20, 19, 18, etc. So whatever you have multiplied till 19 factorial, you can store that value somewhere. Just multiply 20 to that, correct? So it would save around 19 multiplication operation that you wanted to do, correct? In simple words, this is memoization. So memoization is nothing but trying to cache the value of the previous processing and use it for the further processing. Is it possible all the time? No. Only for repetitive actions this is possible. For those functions which you are not sure whether the same set of inputs are going to come again or not, then it's an unnecessary headache of using the memoization. Correct? Every optimization technique comes with its own performance problems. So just because somebody else is using, don't use that. Just make sure you have a scenario of a function which is called repetitively, and there's a possibility where you could store that result somewhere. Only then go for the memoization. Okay, why you need to know this concept is not just from the interview perspective, but even when you're writing your day-to-day code, if you start using this memoization concept, definitely you get appreciation by your peers whenever they're doing your code review. Okay. Now let's see a very simple example. So let's say I have a function add. Okay. It will take a number as an input. Then it will return number plus 10. Okay. All it does is this. It will take one number as an input, adds 10 into it and return the result. Let's invoke that. Okay. Log add 20. Okay. So let me run the code. Nothing supernatural happens. It's very straightforward. So we added 20 to 10, which is 30, and it is got returned. Correct. Now let's call this four more times. Correct. So if I run the code again, nothing special happens. We are just getting 34 times. So by now you got the idea what is happening. So every time whenever you invoke the function and passing the same arguments, you are trying to add it to 10 and return the result. Correct. So rather doing the same operation four times, if you can cache this value somewhere, the return of this function, that is num plus 10 value somewhere, and if you can return that result, it will be much easier. Correct. That's what the memoization stands for. Now what I'll do is I'll create a variable called cache. Okay. And here what I do is very simple. So what I'll do, I'll see if a cache has a num. Okay. uh, if it has, then what I'll do is I'll return I'll return cache of num. Okay. If not, what I'll do is cache of num is equals to, don't worry, even if you're not understanding, I'll explain this once again, number plus 10. Okay. Okay. So I'll explain once again what everything that I have coded here. Okay. So basically we have created a simple JavaScript object, and inside that what we're checking if cache of num. Correct. So cache of num here stands for whatever the number that we are passing. If cache of 20 exists, then because why? Because though you are adding 10 all the time, number might vary. Correct. Number that you're passing might vary. So you have to keep a check whether you have already added 10 to that number or not. When you have added that number already, so then it will be present here. Cache of num is equal to num plus 10. So I'll also show the object notation in a while. But in very simple words, first time you call this function. So cache of num doesn't exist. It will come here. So cache of 20 is equal to 20 plus 10, which is 30. So now cache of 20 is like an object like this. Okay. Cache of 20 is an object like this with a value of 30. Okay. Next time whenever you invoke it, so let's say you have cache of 10, which is 20 like this. So here you are checking whether cache of num exists. If cache of num exists, you return the cache of num itself. Okay, very simple. So now let us put a log here. Log, log, okay, inside regular processing. Okay, and this is inside, I'm sorry, below one is the regular processing. Okay, inside regular processing, and this is the inside cached processing. Okay, let me run this. See, once it went inside a regular processing here, then next three calls went inside the cached processing. So that means whatever the addition operation that was happening here, that is saved. Correct. So system, whatever the CPU that was allocated to this now is can be used for some other purpose. Correct. So this may not be so useful with respect to add example, but let's say you are doing a very complex example, like I said, the factorial. So in that case, it will be very beneficial. Correct. Now let's say rather passing 20. Okay, one more thing I'll do just for your understanding. I'll also try to log the cache. Okay, how the object looks like. Log a cache. Correct. So cache is first empty, then cache is 20 comma 30, 20 comma 30, 20 comma 30. Now you pass 20 twice. Let's say you pass 10 twice. Okay, 10 twice. What will happen? So here inside regular expression, inside cached expression. For 10, again it need to go for a regular processing once because it is not cached. So it is cached once and then it is returning the cached value. Correct? So it's very simple to understand this example. Why I write a simple example, that's my specialty. So where I'm good at giving a very simple example for a complex topics. Okay, let's say if I started writing this for a factorial, most of you would have stopped watching the video. Correct? And in the interview, every time they will not ask you to write a complex example. They would just want to know whether you are aware of the concept or not. Correct? Now, Easy example you understood. Now let's get into complex example and see how to solve that. Okay. So before I start reading the complex example, so I think it is close to now 9 minutes 30 seconds. In case if you liked so far whatever I've taught, please like this video on YouTube and comment whatever you're feeling about the video. In case if you're not subscribed to my channel, please subscribe to my channel. I always say this somewhere in middle of my video because as I always say that by liking lot of many likes if I get for the video, YouTube starts showing my videos for the lot of people. If a lot of people start watching the video, then a lot of people start subscribing to me and following my videos. Basically, the videos become popular. When videos become popular, there's a high chance somebody clears the interview. All I have is that noble cause helping people to clear the interview. I can succeed only if you like and comment for this video and subscribe to my channel if you're not already subscribed. So please subscribe and share these videos with your friends if they're preparing for their interview. Okay. Now let's start with a slightly complex example, which is a Fibonacci. So Fibonacci series, everybody, I think if you're any sort of a graduate, whether engineering, BSc, MSc, any sort of a graduate you are, anything related to computer if you have done or maths you have done, you might have heard of Fibonacci series, correct? So Fibonacci series in simple words, let me first write that. 2, 3, 4, 5, 6. So this is a regular number. Uh, Fibonacci of 0 is 0. Fibonacci of 1 is 0 plus 1, which is 1. Fibonacci of 2 is 0 plus 1, which is 1. Fibonacci of 3 is this one. Fibonacci of 2 plus Fibonacci of 1, which is 2. Fibonacci of 4 is Fibonacci of 3 plus Fibonacci of uh, 4 is 3 plus 2, that is 2 plus 1, which is 3. Fibonacci of 5 is 3 plus 2, 5. Fibonacci of 6 is 5 plus 3, 8. Okay, very simple. I think all of you might have studied Fibonacci series in your graduation time, or if you're still graduating, you might have just now learning this thing in your graduation. See, Fibonacci series has a lot of advantages, the golden quadrilateral, etc., and how the tree branches out. There is a lot of concepts beyond Fibonacci, but that is out of context for my video. But my video is focused on how to write a Fibonacci for a given number. Correct? Let's say you pass 5, you should get a Fibonacci as 5. Fibonacci of 6 is 8. Fibonacci of 2 is 1. So this is what you want to do in the example. Let's get a simple recursive example. I'll also draw and show you how the Fibonacci works. And then let us add the caching and I'll explain why caching necessary, how it will definitely help the execution of the program. This is again very, very important topic for the interview. Please watch the video till the end. Do not skip. Okay. Now, let's first write a normal Fibonacci function. Fibonacci. Somebody calls it Fibonacci. I'm calling it Fibonacci. I don't know which is the right pronunciation, but I've heard both in the internet people saying. So I'm just sticking to Fibonacci. In case if I'm wrong, please add the comment. Probably in future I'll just correct myself. Okay. So Fibonacci, this series takes a number. Okay. So what are the possibilities? Let's say, see, I would have not erased that number. So 0, 1, 2, 3, 4. So Fibonacci of 0 is 0. Fibonacci of 1 is 1. Fibonacci of 2 is Fibonacci of 1 plus Fibonacci of 0. That is 1. So Fibonacci of 3 is 1 plus 1, 2. Goes on. Correct? So now we have certain conditions here. So I'm writing a recursive solution. I'll explain step by step. Don't worry. So recursion means always there should be a base condition which is satisfied. Then only the recursion will close the execution or stop the execution. So if num is equals to 0, then what you are doing? You are returning 0. Correct? If number is, because Fibonacci of 0 is 0, Fibonacci of 1 and if Fibonacci is 1 or 2 is 1. Okay, if num is 1 or num is 2, then you are returning 1. If not, what you are returning? If not, you are returning Fibonacci, you're calling the above function again. Okay, Fibonacci of n minus 2 plus Fibonacci of n minus 1. Okay, I'm just commenting this. So you got to know why I'm doing n minus 2 plus n minus 1. We already discussed. Fibonacci of 4 is Fibonacci of 3 plus 2. Fibonacci of 4 is 4 minus 2 is 2. 4 minus 1 is 3. So we are doing the same here as well. Okay. So Fibonacci of n minus 2 and Fibonacci of n minus 1. Let's first run the code and make sure we are getting the output as expected. Then only let us start the explanation. So Fibonacci of 4 is 3. Correct? Let's see, are we getting Fibonacci of n minus 2, n is not a number, I'm sorry. I think you all might have noticed this and waiting for me to correct, I'm sorry. Okay, n and num I missed. So Fibonacci of 4 is 3. Fibonacci of 5 is 5. Fibonacci of 6 is 8. Okay, So let's say Fibonacci of 6 I want to calculate. Okay, let's calculate the extremities. Fibonacci of 0, Fibonacci of 1, Fibonacci of 2. Vasant, why you are doing 0, 1, 2 and all again and again? See, why I do this is we always have to track the extremities. No matter how confident you are, the least values and the highest values, whatever your input, please validate that even in the interview. Because other case it will work, but the extremities it will fail. Now, so Fibonacci basics you understood, correct? But let me give you the explanation. The code is working. Let me give the explanation. So let me draw. As you always know, my drawing is not that good. Okay. So now you have to calculate Fibonacci of 3, correct? What is Fibonacci of 3? Fibonacci of 3 is Fibonacci of 2 plus Fibonacci of 1, correct? What is Fibonacci of 2? You already saw. Fibonacci of 2 from the code is 1. Fibonacci of 1 from the code is also 1, correct? So if you go back here, so Fibonacci of 2 is 1, Fibonacci of 1 is 1, so Fibonacci of 3 is 1 plus 1, 2. So Fibonacci of 3 is 2, correct? So Fibonacci of 3 is 2. Even if you see in here in the example, Fibonacci of 3 is 2. Simple words, I am not taking 5 and 6 because it's difficult to draw for me. Definitely you can try and draw and analyze this. Now you might have got some idea why we need memoization here, correct? Because let's say now Fibonacci of 2, let's say I have not put that if condition, like Fibonacci of 2 then return something. So let me delete, sorry I can't delete. 1 second, let me select it. So Fibonacci of 2, again if I had not put the if condition, it is fib of 1, correct? Fib of 1 plus fib of fib of. So here fib I mean the function. Fib means the Fibonacci recursion function that I'm invoking. Okay. Fib of 2 is fib of 1 plus fib of 0. See here also you have fib of 1, correct? Here also you have fib of 1. And when this tree extends, there are a lot of different scenarios where these values will repeat, and we unnecessarily calculate this again and again. So there has to be a way where we can eliminate this computation and cache this, correct? So how we can do that, I'll show you. This is where memoization will come into picture. Why I gave a factorial example and not showing factorial example is factorial I already explained. That is something a homework for you. Write a memoization function for factorial. Add the code in the comment section. I always leave the code that is posted by the candidate, the viewers. No matter how much I get, I will streamline and do something on a daily basis and give my feedback. Please write a memoization code for the factorial and add it in the comment section. Okay. Now, what I'll do here is, so we need to cache the value, correct? As it's a recursion, the cache should be something that is passed every time, correct? Rest is very simple. You know it. If same how we did, if cache of number return cache of number, correct? Then what we have to do, somewhere the cache of num has to initialized. Here you are initializing it. That's all. Very, very simple. Just 2 lines of a code. Normal function become a very optimized function. Correct? This is about the explanation. Let me explain this again. Okay. Now, if cache of num, return cache of num, we are adding a value. First, let us run and see we are getting the right value. I think let me try running 10. I think 10 should be 55. 55. So the code is working well. Vasant, why you are not passing cache here? It is taking 2 arguments. In year 6, I think you all know. I'm initializing this in default value of empty object in case if you caller has not passed anything. Okay. So cache is empty now. What we are doing is same. So whatever the value we got right here, the fib of 2 probably we are caching it. Fib of 1 we are caching it. Fib of 3 we are caching. So whenever next time when fib of 3 it comes, we don't do fib of 2 plus fib of 1, again fib of 1 and fib of 0. Fib of 3 is already cached, just return that value. So this will save so much of a computation whenever you are doing a very big number Fibonacci. So this is about this video. To summarize all the things that we have discussed here, first thing, you need to know what is memoization definition. Simple memoization example like the add one which I showed. slightly complex memoization example like the Fibonacci series I explained, or the factorial homework that I gave you. You have to write a factorial homework, huh? Otherwise you will not master it, because I have mastered this. You will master only when you try to attempt it. Write a factorial function without recursion, sorry, without a memoization, then try to add memoization layer on top of it. That is the right way of learning it. Write the code, make a gist, or write a medium blog, get the link, put in the comment section, or add the code itself as it's a small function. I'll validate the code and give my feedback whether this is right or not. Okay. um, I think that's all about this entire Fibonacci series. If you like the video, please like it on my YouTube channel. Share the video with your friends. Let them also get benefited from this. Do not forget to comment. If you like whatever I made, comment. If you not liked whatever I made, please comment. I think that has a positive feedback for me to improvise further. If you not subscribe to my channel, please subscribe. This code, I don't think any special code is here, but still I'll try to add this code into my GitHub repository and link in the description. Please copy the code and practice on your own. My Medium handle is in description. Follow me on Medium. Lot of beautiful articles I've written. In fact, the memoization, I wrote this article almost an year back. Okay, so many followers are there for that article as well. So you can read my Medium articles also, and follow me on Medium and start my GitHub projects as well. Thank you so much for watching. Catch you in next video.